The nodal analysis question. Actually, the question is asking for to calculate Ix, and we can do it in a number of different ways. Now, when you look at a circuit like this, you might notice that when you have 4 milliamps coming this way, you should really have 4 milliamps going this way. The reason is, if we have current coming this way, it has to have the current feeding into the right side of the circuit of the equal value. This 4 milliamp coming out of this node to the left is a combination of these two currents coming in. We can call this as I1 and I2, and that will be I1 and I2. So if you think about it this way, you can sort of see that the two currents that are coming in here really are merging to combine to become a 10 milliamp supply that is going up. So really what we have here is a single supply that is going from this node to this node of 10 milliamps. But for the nodal analysis, we don't really need to worry about this. We can just take our reference here, identify the known voltages. In this case, we know this voltage. This is 2 volts. Therefore, we know this voltage, which is 2 volts. We don't know this voltage here. We can call this VA. And then we can solve for VA to calculate the currents that are running through this resistor, which is IY and IZ. Once we have those, we can say that Ix equals to IY plus IZ. So now let's construct a node voltage expression for node A. We have VA minus 2 volts divided by 3 kilo ohms plus VA minus 2 volts divided by 2 kilo ohms plus the current that is leaving to the right and to the bottom, which is minus 4 milliamps and minus 6 milliamps and minus 4 milliamps equals 0. So the sum of these two is minus 10 milliamps. So we need to get the denominators, common denominator here. So we have 3, 2, and we need to multiply this with 6 kilo ohms. What we end up having here is 5 VA minus 4 and 6, that gets us minus 10 volts plus 6 kilo ohms times minus 10 milliamps, that gets us minus 60 volts equals to 0. So from this expression, we end up having VA equals to 70 volts divided by 5. That is equal to 70 divided by 5 is 14 volts. If we know what VA is, then we can calculate IZ. IZ equals to 2 volts minus 14 volts divided by 2 kilo ohms. And we also have Ix, which is 2 volts minus 0 volts divided by 2 kilo ohms. And the sum of the two, sorry, this is IY, sum of the two is our Ix. That is equal to, we have minus 12 volts plus 2 volts divided by 2 kilo ohms. That is minus 10 volts over 2 kilo ohms. Ix equals to minus 5 milliamps. Now let's try to verify our results to see if this makes any sense. If VA is 14 volts, how much would be the current coming out this way? Because the currents that are leaving this node has to sum to 0. So the current leaving this way would be, let's call this IW. Okay, so we are trying to do some verification here. IW equals to VA minus 2 volts divided by 3 kilo ohm. That is equal to VA was 14 volts, that makes 12 volts divided by 3 kilo ohms, that is 4 milliamps. And IZ was from up here, we had minus 12 volts divided by 2 kilo ohms, that is equal to minus 6 amps. So if IZ is minus 6 amps, the current leaving node VA will be minus IZ. So we have minus IZ plus IW plus minus 6 amps, 6 milliamps, plus minus 4 milliamps equals to 0. Our minus IZ would make 6 milliamps, missing a milli here, plus 4 milliamps minus 6 milliamps minus 4 milliamps equals to 0, and that is correct.